Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. The first one I have there now is 2016. Calculus is normally on paper 1. So this question says that if y is equal to x sine 1 over x, find dy dx. Okay, I'm going to give you a few minutes to give it a bash and then we'll take a look at it. Okay, so we're going to have a look at the 2016 question. So part A of this question was differentiation from first principles. So that solution to that particular part will be up with the calculus playlist as well. But if we have a look at part B, y is equal to x sine 1 over x, find dy dx. And part 2 then of that same question, find the slope of the tangent to the curve y is equal to x sine 1 over x when x is equal to 4 over pi. Okay, so if we have a look at this, the first thing I see is that it is a product rule. And why is it a product rule? Well, I see a function there in x, and I also see another function here in x. Okay, so it's a function multiplied by a function. So u is equal to x, v is equal to sine 1 over x. Okay, and I'm going to write this as sine x to the minus 1. Where did I get that? I'm getting that from the rules of indices here. Okay, so where I said you'll end up using this quite a bit when it's underneath the line, you bring it up by changing the power, changing the sign of the power. So that's why underneath here, that x was to the power of 1. When I bring it up, it becomes x to the power of minus 1. Okay, so if you remember the product rule, it is this one here, u times dv dx. So dy dx is equal to u times dv dx plus v times du dx. Okay, so to do that, there's my u term. I need to figure out what du dx is. That's 1. I also need to differentiate v to give me dv dx. And I get sine becomes cos x. So note I haven't changed the angle. So whatever angle that is stays the same here. Okay, but what I must do now is multiply it by this part differentiated. So this is a chain rule. So if you see there's a 1 over x function sitting inside the sine function. So those two functions are chained together. Okay, the main function, the master function is sine, the inner function is 1 over x. So I've differentiated the outer one, sine became cos, and then I multiply it by, if I differentiate x to the minus 1, take down the power, reduce the power by 1. Sorry, I've run off a little space there. Rather than confuse it, let me just give myself more space. Sine becomes cos, and I multiply it by, take down the power, so it's minus 1x, and subtract 1 off the power. So minus 1 becomes minus 2. Okay, so if we tidy him up a bit, he becomes cos x to the minus 1 is 1 over x. And I'm multiplying it by x to the minus 2, again using that same reciprocal rule, becomes 1 over x squared. So you can see I swing things up and down all the time. So from below the line to above the line, from above the line to below the line. We tend to write them as positive powers. So that's why the -2 is written like this to bring it below the line. And if I just tidy that up, we tend to put the x squared terms first. So dv dx is going to become 1 minus 1 over x squared cos of 1 over x. Okay. Now let me know if any of that doesn't make sense. Okay, so what do we do then? Well, we just sub it into our product rule. So dy dx then becomes u, which we get from here, x times dv dx by minus 1 over x squared cos of 1 over x plus v times sine of 1 over x times du dx. Okay, so let's have a look. So an x there cancels with one of the x here's. So I'm left with minus 1 over x cos of 1 over x plus sine of 1 over x. Okay. Oh, I might just write it the other way around so that that minus doesn't get lost. But it doesn't really matter. You didn't have to do that last line. Okay, and that is dy dx. There isn't a whole pile more we can do to simplify that. Okay, and then I'll do the next bit, which is here. It says, find the slope of the tangent to the curve y is equal to x sine 1 over x when x is equal to 4 over pi. Give your answer correct to 2 decimal places. Okay, so I'm going to draw a little graph here. And I'm going to draw a graph. So x times sine 1 over x. So I'm not too awfully sure how that looks like. So I'm just going to draw a general sine wave, okay, just as an example. Because what I want to explain is what does it mean, slope of the tangent to the curve? Okay, well, if you look at what we found this big formula, and that is dy dx. And dy dx is slope. Okay, why, when it's a curve, do you not get just a single value for slope? Well, the reason for that is slope changes as that curve transverses over. So in other words, we have a positive slope here. Then at the very top, we have a slope that's equal to 0. We then would have a negative slope. We'd have another slope equal to 0, a positive slope equal to 0, and we're on the way back down again. So you can see it really does depend where you are on the x-axis as to what that specific value of slope is. Okay, so for that reason, when you get the slope of a curve, you can't get a single number. It's because it changes. So instead, you get a formula for slope. And then if you want to know, for example, that value there is 5. If you want to know what is the slope at 5, well, what you do is you sub in then 5 for x, and you work out what your actual slope is at that point. Okay, so that's what's happening here in calculus. Right, so what does it mean then, find the slope of the tangent to the curve? Okay, so I'm just going to zoom into the curve now for a minute. And I'm just going to pick a point on the graph and I'm going to draw a line. Okay, so what I'm drawing is a tangent to this curve. Okay. Okay, so imagine that's a tangent. It's not as bad as my normal drawing, but anyway. Okay, so what's this question asking you, right? Well, if I tab down there, and I will say that's x being equal to 4 over pi. Okay, that's that value here. What this question is saying is that if you find out the slope of the curve at that point here, okay, just right at that point, you will get the exact same answer for the slope of the curve at that point as if you basically got the slope of a tangent that was drawn at that point. Okay, so as you know, if you get the slope of a line, it's just a single value. Okay, because the slope or the slant or the rate of change of that line doesn't change at all. So the slope of the tangent at that point of that line is the same as if you got the slope of the curve at the point 4/pi. Now that piece of theory just takes a small while to get your head around, okay? So in other words, to do part 2 then, what you do is you take slope, and slope is dy dx, it's rate of change, it's slope of a tangent to the curve, it's called all of those things. And you sub in, so I'm finding dy dx when x is equal to 4/pi, and it becomes sine of 1/4/pi minus 1/4/pi cos 1/4/pi. Okay, and you put that into the calculator, and I'd like you all to try and tell me what you get for that answer. It's not the most straightforward to get into the calculator, hence the reason I'm asking you to do it. Okay, so the answer to this question is 0.15. Okay, just be careful how you put it into the calculator. It's quite hard to put it in. I just want you to draw your attention to an incorrect answer, which is minus 0.7716. Just in case anybody who's doing the question gets that, what has happened in that case is that your calculator is in degree mode. So regardless of the chapter that you're doing, if you have a pi as the angle, know that that's radian mode, okay? If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.